Hi everybody, and welcome to the second installment of infrared spectroscopy. Today I'm going to be focusing on question 3 from your homework, because a few people have asked me about it. So infrared spectroscopy is not a difficult topic as long as you understand its limitations. Its limitations are that it can only tell you what functional groups you have in a molecule. It cannot tell you anything about their position. It cannot tell you how many of a functional group, so it can't tell you how many carbon-carbon double bonds, for example, or how many alcohol groups, OH groups it's got. It just can't do it. It can just tell you whether they are in the molecule or not. Typically, I keep an eye out for these functional groups. I keep an eye out for this shaped peak, very familiar shaped peak, a round peak. OH alcohols, which is between 3,230 and 3,550 centimeters to the -1. I am reading these values off, by the way. I haven't memorized them. You get these in the exam. I'm keeping an eye out for a sharp peak at 1700, a big peak nearly down to the line, typically 1700 wave numbers, very sharp, representing a C double bond O, and that is 1680 to 1750 centimeters to the -1. That's what you'd say in the exam. I'm looking for this sort of very familiar combination of an OH acid peak, which is 2500 to 3300 centimeters to the -1, combined with a C double bond O, and together these tell you that you're dealing with a carboxylic acid, a COOH group. And then finally this needle at 1600, which doesn't go all the way down to the line, doesn't go as far as the line. It's often very, very sharp, 1600 centimeters to the -1, or actually, what's it say on the data sheet? 1620 to 1680 centimeters to the -1, and that is typically an alkene. So these are the 4 that I look out for, because they are the most informative. All right, let's have a look at the questions which are here. Okay, so what have I got? I've got hex 2ene, 1, 2, 3, 4, 5, 6, hex 2ene. I've got pentane, 1, 2, 3, 4, 5. I've got methyl propan 1-ol, prop is 3, 1, 2, 3, propan 1-ol, put an ol on the end, methyl propan 1-ol. Pentane 3-one, 1, 2, 3, 4, 5. Pentane 3-one, so a ketone in position number 3, 2-methyl. Butanol 1, 2, 3, 4. Aldehyde is a double bond O, and we draw the H on as well with aldehyde skeletally. Butanoic acid 1, 2, 3, 4. Double bond O, OH. Question for you for later on: how could you turn butanol into butanoic acid? And probably it's worth saying, and what can butanol be made from? And the last 2 are drawn for you. Propyl ethanoate is an example of an ester. You came across these maybe in GCSE, but we haven't done them yet at A level. It's got a C double bond O, it's got a carbonyl, it's got a CO bond. It's got 2 of them, in fact. And nitrobenzene, this is a benzene ring. Now, this benzene ring is not made up of C double bond Cs. You do a bit more about that in year 13, so you're not looking for C double bond Cs there. All right, so the first thing I'm going to do, I'm going to look at these structures and see, well, you could do it either way. I could look at the spectra and look for any familiar shapes. I could look at the structures. So if I look at all these structures, there's only one of them there with an alcohol OH, and that is methyl propan 1-ol. This one here. So there should only be one spectrum with an alcohol shape. Can you see it? Can you see the alcohol shape? We're looking for a broad finger around sort of 3,000. There it is. It's quite obvious, I hope you see. There it is, the alcohol shape. That, number 3, is methyl propan 1-ol. So that, and I'll write number 3 in there. So we've assigned that one. That was easy. I'm also looking through these. Anything else distinctive? Yeah, I'm going to look for this next. I'm going to look for the carboxylic acid because it's the only carboxylic acid there. It's got an acid OH and the carbonyl group. So we're looking for here. There it is. Typically this combination, and I've drawn that shape out a number of times now. That is butanoic acid, so that's number 7. So those two are quite easy to assign. All right, next thing I'm going to do is I'm going to look. Now, if I look at my molecules, this one might be worth looking for, pentane. Pentane should be easy to spot because it hasn't got an OH acid, an OH alcohol, it hasn't got a C double bond O, so actually the only peak we should see is CH peaks at around 3000. Alright, so first thing I'm going to cover up the fingerprint regions on 1 and 2. Once you cover up the fingerprint regions, it becomes obvious that the important peaks, these two have both got a C double bond O at around about 1700, or in the exam I would write between 1680 and 1750. Between 1680 and, oops, what have I done there? And 1750. This peak here is just a CH peak, which exists between 2850 and 3300. But they've all got a CH peak, so it's never a useful peak, really. And then looking across the 5 and 6, I cover up the fingerprint region. And when you cover up the fingerprint region, I'll do spectrum 6 first. Spectrum number 6 has still got a C double bond O peak, so that is a carbonyl as well. Spectrum 5 does not have any interesting peaks. This is a sharp peak at 3000. That's CH. So what hasn't it got? Well, it hasn't got an alcohol peak here. It hasn't got a carbonyl peak here. All right, this is definitely just pentane. And we know that because it hasn't got any of the other peaks that we're looking out for. So that is pentane. Pentane is 5. So we've done the first 3 quite easily. All right. By looking out for obvious peaks, or by looking out for any obvious missing peaks. So I'm just marking off the ones that I've done so I don't end up choosing them again. Right, so what am I left with? Well, I'm left with, if I look at the molecules, I'm left with a molecule with a double bond, so an alkene. I'm left with 1, 2, 3 molecules that have got a carbonyl. And I'm left with 1 molecule that I don't really know what to do with, nitrobenzene, because we haven't really done about benzene rings or anything like that yet. So I'm going to go on the hunt now for hex-2-ene. Hex-2-ene has got a needle at 1600. I'm looking for a peak that shows this bond, which I think should be a needle of a peak at 1600 centimeters to the -1. I'm going down to the bottom here because I know where it is, basically. So I'll cut to the chase. Right, if I cover up the fingerprint region on this one, I will see, where have I put my pen? See, it's not just in class that I lose my pen. I've lost my pen literally in a tiniest space. Got no idea. I just have to carry on using this this filter. Right. So, if I cover up the fingerprint region, you end up with this obvious, very, very sharp peak. This is a C double bond C. That's the needle that I referred to at 1600, and it occurs between 1620 and 1680. That's a C double bond C. That 1, 2, 3, 4, 5, 6. That is hexene. Now, I know that some of you are at home thinking, well, couldn't 4 be hexene as well? Because if you cover up the fingerprint region, that's what you're left with. And some of you might well be looking at that and they going, that could be a C double bond C. And I agree with you, it could be. It's in the right place, it's sharp, it's needle-like. So really, it would be very difficult for any of you lot at home to actually say with certainty that which one of 4 or 8 is hex-2-ene. I'm telling you now that it's 8. 4 to me looks like a benzene, a nitrobenzene. So you wouldn't be asked anything like that in the exam. What you could be asked in the exam is a question that says, how could you find out definitively? Should have chosen a word I could spell. Definitively. Has it got an E in there? Oh, I don't think it has. How could you find out definitively that 8 equals that? Okay. So do you know how you could find out for sure? What part of the spectrum could we use to find out for sure that that 8 is hextuene? Okay. I'm going to tell you the answer in about 5 seconds. How could you find out for sure that this was hextuene and not nitrobenzene? Alright, well the answer is you could look into the fingerprint region and compare this spectrum to a spectrum that you already know. Alright, you could look into the fingerprint region and compare that spectrum to a spectrum you already know. Alright, so if you were at home and you got a bit stuck between 4 and 8 and you weren't sure which was which, that's fine if you got stuck there. That was a good place to get stuck, because actually there's no obvious answer. I just think, from my experience of looking at a lot of infrared spectra when I was growing up, when I was in university, I think this looks a bit more nitrobenzene. Alright, and that peak here is a very obvious needle at 1600 to my eyes. That leaves us then, if I just tick off, so we think we've assigned nitrobenzene was number 4 and hextuene was number 8. And that leaves us with 3 more molecules: 2-methylpentanthreone, butanal, and propylethanoate. Now, in terms of infrared spectrum, now these molecules are all very, very different, but an infrared spectrometer does not see them as being particularly different, because really, this molecule is made up of CH bonds and C double bond O's. This is made of CH bonds and C double bond O's. This is made of CH bonds, C double bond O's, and a few CO bonds, or a couple of CO bonds. But CO bonds, if I get my little table of data out, remember from last time, CO bonds appear in the fingerprint region, so we don't go there at A level. I don't think you should go there. That is my advice to you. Right, don't go. Found my pen. Did you hear it fall on the floor then? Don't go looking for CO bonds. Alright, so what I'm trying to say, long story short, is there are these 3 spectra left and there are 3 molecules, and I don't know which one is which, and you don't know which one is which, and there is no way of knowing just by looking at them which one is which. The only way you can find out which spectrum matches which molecule is to compare the fingerprint regions of each molecule with a known spectrum. Alright, that's it, and that's the end of the homework. Okay, that's where you should have stopped. Some of you will have convinced yourself that you'd found maybe a CO peak at around 1000. You might have tried to go, oh, maybe this is a CO peak. Yeah, but you've got one that looks a bit like that here as well. And you've got one that... Do you notice how it's impossible? When you're in the fingerprint region, it's impossible to go there because there's so many peaks. All right? So that was the point of the homework. The point was that you couldn't actually do it. All right? Cool. I hope you understood that. Right then. So that's the end of that homework. The final thing I want to say is just something about things that you could be doing during lockdown when I haven't sent you out any extra work. So there's more stuff coming from me every week, but more work coming. But here's something, just a general idea for how you should be thinking about your chemistry. Actually, I've got a totally clean sheet of paper. Right, here's the way I see chemistry, and the people... What I want to talk about is how you get successful at this subject. People who are successful chemists and who do well at A level, firstly, they spend their time learning the facts. Okay, so you might learn facts, and that means just sitting down and going through repetition, learning some solid factual information. So here's an example of some solid factual information. This here is K2Cr2O7. That is acidified potassium dichromate. And I wrote that down, and I know the formula for it. And I know that acidified potassium dichromate is an oxidizing agent. I know the formula for acidified potassium dichromate, so I know that one fact. Here's another fact that I know. I know that if you take a primary alcohol, you can turn it into an aldehyde, and you can distill it off as it forms. And I know that if you reflux it, you can turn it into a carboxylic acid. I know if you take a secondary alcohol, you can turn it into a ketone, and tertiary alcohols don't get oxidized. And you can use an oxidizing agent. I know that if you take an alcohol, and you add concentrated sulfuric acid, you can dehydrate that alcohol to make an alkene, because this H and this OH disappear. So I know concentrated H2SO4. These are facts. These are things that I know. It's not interpretations. I know these facts. Other things I know what an alcohol looks like on an infrared spectrum. I know what a carboxylic acid looks like on an infrared spectrum. I know what a carbonyl group looks like on an infrared spectrum, and a C+C looks like on an infrared spectrum. I know lots of facts. I know how to name alcohols, and I know how to do things like empirical formulas. So what I'm trying to show here is that you've got these individual facts that you have to be sure about. And what you do there is you get your specification, specification, or your textbook, or both, and you just go and you learn facts. And that means that when you get a hard question like the one that we did yesterday or the other day, what you need to be able to do at A level is you have to make links. Now, the question that we had yesterday, last video I made, it starts off by saying compound E is a branched chain haloalkane. Now you need to know what those words mean, branched chain and haloalkane. You need some facts. It says it was found to have a composition by mass. You need to know about empirical formulas. There were 2 peaks for molecular ions. You need to know about mass spec, otherwise that sentence can throw you. It tells you that E reacts with sodium hydroxide. So, oh God, what's that then? So you need this fact. You need that haloalkanes react with sodium hydroxide to make alcohols. It then tells you that some infrared spectra are shown. It tells you that they undergo dehydration with conc sulfuric acid, or does not undergo conc sulfuric acid. It says reacts further with acidified potassium dichromate. All right. So if I go through this question, it starts off with an empirical formula. It then says that you have a haloalkane that reacts with OH-, so you now know you're dealing with alcohols. It then talks about it cannot be dehydrated, so it links to this. It then says that it was added to acidified potassium dichromate, which I've revised as an oxidizing agent, so that links to this. And then it gives you a spectrum of a carboxylic acid and an alcohol, and you have to be able to go backwards and work out what was what, and ultimately be able to name the alcohol, or name whatever compounds you had. The point I'm trying to make here is, if you didn't know, in this case, if you didn't know about dehydration of alcohols, you miss a link in that whole argument and you are totally stuffed. You might be able to pick up a few marks here or there, but what tends to happen is panic sets in because you don't understand what dehydration with concentrated sulfuric acid means. If I ask any individuals in the class, people who really struggled, if I ask you, do you know your nucleophilic substitution? Yeah, I know that fact, sir. I know this fact. I know this fact. But you miss important facts because you haven't kept on top of your work. All right? Now you have the perfect opportunity to go back and learn all of these individual facts, to start getting your knowledge up to scratch so you don't have any massive gaps. It's a really, really tough ask, but it will boost your grade by 2. All right? If you start patching up all of these missing bits of knowledge. All right, so that's just one example, but there's loads of examples how these ideas link together. It's the linking of ideas that's really, really important. But to link ideas, you need to have those ideas or those facts solid in your mind in the first place. So go away, do some hard revision, this is the sort of stuff that parents can check with you or guardians can check with you. I've learnt this fact, check me on the fact. They can't help you particularly with this question, unless they're chemists, but they can help you to learn the facts. All right, I hope that wasn't too waffly. Well, now you know. If you ever watch this video again, don't watch that last bit. All right, good luck with it all, everybody. I do miss teaching you, and I'm looking forward to getting back to school at some point. So, yeah, good luck with this homework. I'll give you some more stuff either towards the end of this week or next week. All right, thank you.